Okay, so things today are a little bit different. I'm currently doing this in the car on my laptop, so using a trackpad, so go a little easy on my mouse movement. But here we've got Advent Code Day 19. Let's see how this goes. Hopefully it's a quick one. Knock on wood or something. Okay, messages. Okay. Puzzle input. Okay. Looks like we've got a bunch of grammar type things and then a bunch of A B A B A B A B A B stuff. Okay. Okay. So Sea Monster sent you the rules valid messages should obey and a list of received messages they've collected so far. Rules for valid messages are numbered and built upon each other. 0, 1, 2, 1A, 1, 3, or 3, 1. Great. Some rules match simple character. Okay, so this is implementing a grammar, essentially. I don't really know how to do that, but we're about to figure it out. Yeah. And a list of received messages collected so far. Rules. Nice. Okay. Completely match rule 0. Okay. Okay, so my first question is whether or not we just generate everything that the grammar could possibly generate and just put that all in a set and go from there. But first, I think we're actually going to be able to use our parser here, but we're going to need to make a couple different cases. So it looks like looks like there's almost too many different cases. I'm not sure if I can do it quite that way. So rule 0 is the one that we're really looking for. Yeah, I think I might just parse this. Okay, so every single rule number maps to a set of lists, I guess? Or each list is a thing that you can try matching. So in this case, it's a single. Okay, cool. Yeah. I'm happy with this. So let's ditch the compiling stuff because I think just doing this by hand is going to be easier. For line and L, and then what we want to do is if line dot starts with A, or line dot starts with B, else. Rules is equal to a map, and it's going to be a map from integers to lists, set of lists. Else we say tokes is equal to line dot split on space. And then we say ID is equal to tokes of 0, and then cut off the last character, and then we turn it into an integer. Print ID. X equals 0. Well, actually, no. We want to say. Let's define a function that is def match, and it's going to take in a string and rules, and then return true. How many messages completely match? Matches equal to 0 if match of line rules matches plus equals 1, print matches. Okay. So index error, index out of range, interesting. Ah, we forgot the empty line case. elif line. Great. And it looks like 102, 125, those are the numbers we want to be seeing. 17. Great. Cool. And yeah, cool. Looks like we're starting to parse things out all right. So we've gotten the ID. Now we need to parse out the rule. Let's just case this out. If tokes dot, let's hear it. We could just do the case of, let's just get rid of the A and B case because there's exactly one of each of those, which I know is a little, we're exploiting that a little bit, but if tokes of 1 equals A, rules of ID is equal to a list containing the letter A. Let's change this a little bit. Or tokes of 1 B. Then we want to say is equal to tokes of 1 of 1. Just to get that character. And then at the end, let's also print rules. Print rules. Great. 71A, 72B, that's what we want to see. Okay, so else. For toke in tokes of 1 to the end, rule set equals set, and rule list is equal to list. If toke equals the bar character, else rule list append int of toke. And then we say if it's equal to or, then we say rule set dot add. Wait, we're not going to be able to add lists because they're not hashable, so we're going to have to add a tuple, I think, instead. Tuple of rule list. Rule list is equal to empty list. Then rule set dot add tuple of rule list. Cool. I think that'll work fine. And I don't see any like things that mix letters and not letters. So yeah, let's try this. Oh, we forgot to add it to the wait, it needs to map to a set of lists. So this is actually slightly wrong. Set. Rules of ID is equal to rule set. Type error, unhashable type list. Nice. And this is online s.add. Ah, right. Instead of a list, sorry. It's a set of tuples, right? Cool, I have lots of things. So let's just look at print rules of 0. 811. Is that right? 811. Hey, okay, so let's look at rules of 17, because that's a different case. And 17 gives us 72, 112, 71, 3. And that's all in our set. That's what I like to see. And another case is 110. 86, 86, great. I think we're doing just fine with our parsing. That's nice. So we've now parsed the things. So now we have to actually do something with them. So now we have this lovely thing that's a string, and we have our rules. So now we need to actually do the work. It's a set of tuples. I think this is going to be recursive. Question is how. Def match helper, and let's say wait a minute. Wait a second. Because if we take an additional rules and then we need to say, let's call it rule set. Let's call it rule list. And essentially what we're passing in now is line, and then we want 0 and rules. So now what we do is we evaluate stuff out, and if it doesn't match, then we fail. So let's think about this for a minute. So okay, we're going to try something. It's probably not going to work because my guess is that it's just too recursively large. In fact, I'm going to do a quick Google search because I don't want to just go down the wrong path completely. Grammar implementation. And that's not working. Okay. How to implement a grammar. Am I not going to get the... Let's try Google. Introduction to Grammars and Parsing Techniques. Okay, I don't think I'm going to learn specific implementation details here, but let's give it another try, or let's just give it a try and just see what happens. So first, what we want to do, so we have a list of rules, and we want to know if this matches. So this is tricky. For rule in rule list. set, or let's call this rule sets, or let's call it rule num in rule list. Rule is equal to rule set of rule num. And now we need to see if rule let's do okay, the rule is set. Let's just call it rules. Okay, so we have this rule set, and this is a set of all the rules. Okay, so had a little bit of trouble last night, had to take over driving because my partner was getting tired driving and we were driving rather late. So, also I lost some of my video recording from stuff that was in this panel when I was poking around looking for some grammar information. So now we're just gonna keep going and see how things go. I was able to think a little bit more about this problem, and I think I have a better idea of how this is supposed to go now. So actually what we really want is just the first number of this, and because essentially each recursive level is only dealing with one rule. So we have rules and there's going to be rule list of 0. Okay, so if S starts with rule, okay, so this handles all of the if you're just a character case. And now what we need to do is iterate through these guys. So for rule for new rule list in rules of rule list of, oh sorry, in rule, because we already got that in rule. So we know that rule is now a set of lists of rules, and what we need to do is recur. So if match of S and then new rule list and rule list of 1: rules. So if this returns true, then return true. Then otherwise we return false at the end here. And I think this actually might just be it. I'm very much not sure. We're about to find out. or it might just run for forever. Oh, what's going on? For some reason the terminal's being a little bit funky. Let's close it and try it again. Oh, it's still not printing things. I'm going to try closing and opening again. There we go, we have this back. Let me make sure the recording's doing what it's supposed to be doing. Okay, you can still see everything. Great. Let's try running. Okay. Can only concatenate tuple, not list, to tuple. Okay, so this just needs to be a tuple. Or this needs to be a list, really. New rule tuple. Now it's just going to be list of new rule tuple. Index out of range. Lovely. That's what I want to hear. If length of S equals 0 or length of rule list equals 0, else return false. So now we're just saying that if either one of these has been completely used up, then we are not, it's not going to work. 124. Is that just it? Oh, I was so close. Man. This really isn't that many lines of code. I thought this was going to run into some sort of recursive problem where there's just too many options and it doesn't quite work. Okay, realize matching rules aren't quite right. To fix them, completely replace rules 842 and 114131 with the following. Now the rules do contain loops and a list of messages. Oh, great. I think I'm okay. I'm doing left recursion, and because this isn't going from 8 to 842, it's going to 42.8. Because it's going from 11 to this first, the first thing that it's trying to go to. Yeah, I think that I know that so these are sets, but we'll see. It might not work. We're going to give it a try. You know what I'm going to do? I'm going to pop these things out into a list. Let's just see if it works first, because if it does, then there's no reason for me to keep doing this. And let's just say rules 2. It's equal to that, and then you know what I'm going to do? I'm just going to modify the input directly. I know this isn't the cleanest thing, but, well, actually, I'm not competing. It's not about speed right now, so instead I'll just do it right the first way. The first time. So first thing I want to do is probably, well, if I can just do this manually right here, I can just say rules of 8 is equal to a set actually, here's what we can do. Okay, Control C, V. Yeah, we'll clean this up a little bit after, but right now this is what I want to do. So first, I'm just iterating through these, and let's change rules to be slightly different. We don't need the rules to. Rules of 8 is equal to set containing two tuples. The first tuple is just 42. And the next tuple is 42, comma 8. And then rules of 11 is equal to set of boop, boop, and this can be 42, 31, 42, 11, 31. Yeah, let's just leave that the way it is. Okay. You kidding? That's how easy. Well, so I just wrote it correctly the first time and literally did not have to change my code for part 2. That's insane. All right. Well, I'll get this pushed up, but yeah, grammars are fun.